Hello, good day friend. Today we'll talk on C# list of type T. T stands for any type. It's a generic collection. So let's start. We'll start with initialization of list. Then we'll see the capacity and then we'll move to count property, and then we'll see different methods. Like we'll start with add, and then AddRange, RemoveAt, clear, contains, InsertRange, reverse sort, TrimExcess, TrueForAll, find, ForEach, BinarySearch. So let's start. So let me first start with initialization. Here in Visual Studio Console application, I'm using .NET Core 3.0, but you can use in .NET Framework, .NET Standard, or .NET Core 2.2 as well. Initialization. Okay, so I will take one list and subtype integer. So I instantiated the list, so I can put value into it like 1, 2. So that is now 1 for each. Okay, now if we go and each of the item, so 1 and 2, the items appeared. Okay, now we'll check capacity. So this was with initialization. So we can do initialization. Let me go back to the code. So if required, you can refer it back. Okay, now if I want to check the capacity is how much space is allocated to this list. So I can do that using this list dot capacity property, and if I run it, you see 0, no space has been allocated. Now if I go to start with, no space has been allocated, but I can make space allocation to this list by telling the numbers 10. So it's 10 items will be added to the list, so the space has been made up for. So integer takes 4 byte in 32, so that means 40 byte space has been allocated. Now this is about capacity. So next comes count. So let's see. So now I will check that. So let me turn on this one so that we can check. So list dot count, how many items are there, it says. So let me run it. Let me hide the capacity, otherwise it may cause confusion. So it ran, and we can see these are the 1 and 2 are the item, and 2 is the count. Okay, now if I go and if I do one thing, let me put it on top of capacity, and if we check the capacity, now I didn't mention any capacity. If I run it again, you see 2 is the count and 4 is the capacity. Okay, so by default the compiler allocates 4 item can be added for 4 item space. Okay, next we'll look in add method. Okay, so I can add item to the list this way. So like 3 added, we can add one more item for 5 item I added. Now let's see. Okay, let me start with 4 item. So if we run it, 1 2 3 4, you can see as we ran count and capacity before adding this item, so it didn't reflect properly. Let me put it down. This is the 4 is the count, 4 is the capacity, 1 2 3 4 are the items, because I'm running the for each loop down. Now I can make it better. Let me to read it properly. So if I run this, you can see count is 4, capacity is 4. Now you will see the magic. If I go here, stop this, and if I add one more item, let's see what happens. Now count is 5, but capacity has been doubled. So that is how list behaves. Now we'll see AddRange. Okay, now this is for add. Now I need to go and start with AddRange. So with AddRange you can add list of items. So if I take another list, list 2, if I take another list of integer, let me straight away do that 7 8, and then I can go ahead and I can add them at one go. So if I press 5, you see 1 2 3 4 7 8 all the items has been added. One important thing I should mention, that in add or add range you cannot add anything other than the type you specified. So if I try to add a string, see, you will straight away get a compiler error. Okay, so it is the type is being checked. So that's the benefit over array list you get in list. So in array list, each of the items get converted to, if you are trying to add an integer or a string or an unsigned integer, it will be converted to object. Next we will see two methods, remove and RemoveAt. Okay, so I'll go to, I'll first start with remove. So let's see, list dot remove, I want to remove item, the first item. So you see the signature, that's the item you have to mention. So if we press 1, if we press F5, you see there are count 7, 1 has gone. Okay, now you can press F5. So even if you require something in between to remove, if we get 1 3, if I press, you see 1 2 3 is gone. Okay, now let me go and try with RemoveAt. Okay, so this is about list dot, this is RemoveAt. So RemoveAt, you need to specify the index. So if I specify the index 0, so let me add this for the time being. So it would remove 1 from the top, so it starts with 0 based index. Okay, so then we will see at clear. Okay, so now we'll look at clear. So let me take 2 items. Fine. Now after that, I'd go and add straight away run clear and we'll see what happens. Now I'm running clear will remove all the items from the list. After this, we'll see contents. So content will tell whether like an items, the list has a particular item or not. So let's see. Let me first comment it out so that we can see, and we can try to find it out from the list dot contents. So I want to check whether 2 is there or not. So if I press F5, it's true, it's there. Now if I try to search something which is not there, like 10, so it's false. After this, we'll see insert and insert range. Okay, so now we have 1 and 2 items. Now if I want to insert something in between, I can do that using this insert. So you see it is taking index where I want to insert at position because 1, because it starts with 0, and what is the item? See, I wanted to insert 0, so it should print now 102. It is 102. Now there is one more insert range. This the reason is, what if I want to insert a list of items? So I can take one more list, new integer, and then let me take initialization, say I have to take 10, 20, 30, and I want to insert that here. So let's do. Okay, now if I try to print, so where we want to remember, insert range takes where you want to insert at position 1, what you want to insert this list 2. So let me run this. See, 10, okay. Now next we'll see at reverse. Okay, so we have 2 items. Let me add one more item for, so that we can better understand the concept. So I can go list dot so it would reverse the list. So we have 1, 2, 3. It should print 3, 2, 1. See, that's printing 3, 2, 1. Now say 1, 2, 3, and we have like this 5, 4, 3. Now this is not very properly ordered list, like 1, 2, and then this is in reverse order. And say we want to fix this, so we can do like this, reverse. If you see, it doesn't take any argument, but there is one overloading, that is, it takes index 0, 1 from 2. How many you wanted to reverse? 3. So it would become 1, 2, then 3, 4, 5. If I run this, see, 1, 2, 3, 4, 5. So these are small tips or small things which would help you when you write your program. Next we'll see sort. So we have a list 1, 2, 5, 4, 3, and I wanted to sort it, so I can press sort. Okay, now if I run it, it should print 1, 2, 3, 4, 5. Correct. Now if it is a very long list, we may not require to run from top to bottom, so we can, like you see, the sort has one overloading method, that is in index, that it starts with from 2 and it runs till 3. Along with that, it also has another option that you can pass the comparer, that how you would like the items to be compared, which was not there in case of reverse. So in reverse, it would just turn the upside down complete stack, it will turn upside down. But in the sort case, you can have a decision making capability, that how you want it to be ordered. But for the time being, pass it on, we'll sort it on the default order, that is on ascending. So you see 1, 2, 3, 4, 5. So that is the difference between sort and reverse. After this, we'll see TrimExcess method. Now, as I initially showed the capacity to here, so if I go and if I put list.capacity, we have 5 items now, 1, 2, 3, 4, 1, 2, 5, 4, 3, 5 items, but the capacity is 8. We still have space allocated for 8 items. which we can definitely take care of. So there is TrimExcess. Okay, it may not be important for small list of items, but if it is a very huge list of items, probably TrimExcess would help remove the unallocated space. So if we run, you see we have the exact amounts of space to the number of items. Now next we will see TrueForAll. Well, TrueForAll is like it checks, it's a condition. The condition you can check for all the item to be true or false. So I can go and I can see TrueForAll. So say we wanted to see that it takes lambda expression. So say I wanted to check whether all the items greater than 10 or not. So if I run it, it would return false. So items are not greater than 10. So I wanted to check if all the items are positive or not. If I run it, this is true. Yes, all the items are greater than positive. Okay, next we will see find. So let me go and do the find. Okay, now it also takes a lambda expression. So if I go and say I wanted to find one item like that is divisible by 3. So it found out that is 3. Now it would return the item itself. Let me hide it. Okay, now there is like if I want to check if there are multiple items which matches the predicate, what will happen? So if I run this, only the first match will be returned. In this case, fine. There is one more method called find all. So if I run this, you see, so it's returning. Okay, generate list. Okay, to see that, what we have to do, we have to go and take it list 2 because it returns an enumerable. It returns another list which are the items has been found out. So now we can check it. Let me see 2 and 4. So this is very beneficial. Next we will see ForEach, and after that we will see BinarySearch, and we'll wrap up with this. So let's start. So like this, there is an inbuilt ForEach loop. So into this is like this. That takes a lambda, and we can run the function, and it's very beneficial. Now you see this crisp small is very beneficial to write something in line. You can definitely write multi-line function here using curly braces. Okay, there is another very good method, that is BinarySearch. It is especially beneficial for say you want to search an item like 3. Very beneficial for long list. Okay, now if I run it, let's see what the output is. See, it didn't give. One second, so it would return the item. I need to write the item. Okay, so if I run, what happens? -3. What is -3? Okay, first of all, how BinarySearch work? BinarySearch work for a long list of items. It's very beneficial. First of all, like it needs like this: 1, 2, 3, 5. This manner. It cannot work like this way: 1, 2, 5, 4, 3. It has to have a sorted list. Once you have a sorted list, what it does, the item it gets, it checks, it targets the midpoint of the list, and it sees that if the item which has to be searched is greater than the item it is targeting, or the less than or equal. If it is the item, like if this 3 is less than this midpoint, it will do the search in this region, not in this region. So this way it's reducing the list by half, and it's becoming very fast and very like high performant search operation. This is very good for long list, because our list was not sorted on proper order. Now I sort it. Now we should find the, so it should be at number 2. 0, 1, 3 would go to 2, 2. So that was about binary search. So that was all about list. Thank